Okay, sure. Let's start, guys, with flotation. Now, when I do talk about flotation here, this flotation is technically a setup where, if you remember in part A, we had learned about three situations. The three situations were, the first one was whenever the weight of the solid is greater than the buoyant force, we used to say that the object was sinking. Second case में, whenever the weight of the solid was less than the upthrust, we used to say that the object is floating. Whenever the weight of the solid was equal to upthrust, we used to say that the object is floating. Here, in this second case, to be very precise, whenever the weight was less and FB was more, rather than calling it as floating, we had a better term where we used to say that the object is submerged. When I try to draw it in terms of diagram, this is how it was looking like. Suppose if I have this as a beaker, and in this beaker, if I have a liquid, let's say that this is a random liquid, okay? And if this is the object, if the object is completely inside the solid, which means its weight is greater as compared to the FB which is going to act on it. So when weight of the object is greater, that object is getting pulled in the downward direction because of its original weight, stating that the object is going to sink in that situation. Wait, sir, if this is like
Must be the other way around.
which one?
2 and 3.
Yeah, 2 and 3? No. Because, sir, like over here, if it's like submerged, then wouldn't this floating one be like half-half? I'll show you how. When I do talk about the second case is I have a beaker here. In this beaker, I'm going to add a liquid. Again, some random liquid. On adding that random liquid, the object will try to go somewhat like this. If its weight is less and if upthrust is more, then the object ka some portion will be outside and some portion will be inside. We call such type of situation as object being submerged. So if you notice very carefully, this much portion of the object is inside the water and the remaining portion which we can see here is outside the water. So we can conclude that FB here is greater than its weight. That is the reason why some portion of the object is outside the water.
I thought
We
that was for the third one.
I'll explain. We can conclude that this situation में the object is submerged. Submerged means little portion inside and little portion outside. When I talk about the third one, third case में, if we do have a container here, and in that container, if we have a random liquid, and in that random liquid, guys, if I have an object, and if this object is somewhat like this, you can see it is exactly with the surface. Such type of setup is going to be called as object being floating in this case. Why? Because here the weight and upthrust, when they both are same, the object will float with respect to the surface of the liquid.
Don't it put above the surface?
If it is little bit also above the surface, then it goes into the second situation. Yeah, floats at the surface. This is floating at the surface. And in this part, that is part C, we are going to emphasize only on this part. Maisha, I hope you are getting it what I'm trying to understand.
Yeah.
Okay, sure.
Yeah.
Let's try to see. So in this part C, we are going to talk about only and only about a term called as flotation. Now, when I do talk about flotation, I take this as my condition into consideration and I try to explain this thing and we try to figure it out. Since in flotation, I know that W is equal to FB, right? Now, we have even learned that W, which is weight, it can be calculated by using a formula called M into G, right? Now, I replace W by mg, okay? And if I need to calculate upthrust on any specific object, we use a formula which is volume of solid multiplied by density of liquid multiplied by acceleration due to gravity, right? If I talk about mass, Satvika, if mass is not given to me, and if I need to figure out what is the mass of the object, how can I try to calculate this mass? I can calculate this mass by using a formula which is density is equal to mass upon volume. Whose density I'm talking about? I'm talking about density of solid. What volume are we talking about? We are talking about volume of the solid. And to be very precise, I'm talking about the total volume here. So here, when I try to cross multiply, I will get mass as density into volume. I replace mass by density. Density, I'm writing it as rho. So we will get rho S into V into G is equal to V rho L into G. You understand, guys, what I have done? I repeat my concepts again. Now, since I know that in flotation, weight is equal to buoyant force, weight has a formula which is m into g. Buoyant force can be calculated by using the formula called volume of solid submerged. Submerged means inside the liquid, multiplied by density of liquid into acceleration due to gravity. Now, since I don't know this mass, to calculate mass, I use my basic formula, which is density is equal to mass upon volume. I interchange and I get mass ka value, which I try to substitute here. So when I try to use it, I get this as my expression. Can I cancel GG from both the sides? So I get a formula. And the formula is density of solid into total volume of solid is equal to this V is volume of solid which is submerged. Submerged means inside the liquid. That is denoted by small v multiplied by density of liquid. Keeping volumes on one side, densities on another side, we get a formula which is small v upon capital V is equal to density of solid upon density of liquid. Easy. I shift this thing there and I bring this liquid here. So I get this as my formula. This is the formula which I need to prefer in overcoming the sums which are related to flotation. Here, if I denote each term, small v represents volume of solid submerged inside the liquid. Very, very, very. Capital V represents the total volume of the solid. Rho S is density of solid and rho L, guys, is density of liquid.
So, will volume of solid submerged inside always be half of the total volume?
No, not necessarily. It can be anything. It can be even 1%, it can be 2%, it can be 3 or 4%. Anything it can be.
But does it have to be like, okay, yeah.
It can be any random thing. Okay. So we need to make a note of this concept that we have it on the screen. So take out your books, guys, and let's try to write it. The sums which we are going to solve related to this formula. Take out your textbook, guys, come to page number 1. Page number
Is
133.
there like nothing else?
There are many give reason based concepts in that. And that give reason
We should
based
do
concepts
that
which we
instead.
have. Huh, beta?
Yeah, it's like it feels better. Yeah.
We have numericals which are based on this thing. That numericals which we do have, they are in our textbook, page 133. So page 133, questions which we are doing are 1, 2, 3, 6, 7, and newtons. 1, 2, 3, 6, 7, 8. We will complete this many questions. Before solving the sums, I'll quickly again revise the formula with you guys so that it's easier when we are going to solve the sums. Okay, we have only one formula here in this situation. The formula is small v upon capital V is equal to density of solid upon density of liquid. When we do talk about small v, what does small v represents? Small v represents volume of solid submerged inside the liquid. Okay. Capital V represents the total volume of solid. rho S is density of solid and rho L is density of liquid. Okay, Kian, can you read the first question for us?
A body is held immersed in water. Name the two forces. A rubber ball floats of water with its one-third volume outside water.
Stop. One-third volume is outside the water. So there is a rubber ball whose one-third volume is outside. So can I say, Satvika, the total volume of the rubber ball, let it be V. So how much portion is outside? One-third is outside. We will write here volume of rubber ball outside the water is 1 upon 3V. So how much will be the volume of the rubber ball inside the liquid?
4.3.
Very nice. Volume of rubber ball submerged inside will be total minus 1 upon 3V, which will be 2V upon 3. Correct? Okay. Let's try to focus ahead. So we got this volume of the rubber ball inside the liquid. What is the next part given to us? Read.
What is the density of rubber?
Okay, now since this is inside liquid, and which liquid it is? Water. So density of water I already know. I can take density of water as 1000 kg per meter cube. I'm supposed to find out what is the density of rubber. So density of rubber is question. Now you guys tell me what formula should I prefer. That one formula which we have, we will try to use that same thing. So the formula is small v upon capital V is equal to density of solid upon density of liquid. Small v is given to me as 2V upon 3. Capital V is given to me as V. That's the total volume. Density of solid I'm supposed to find, and density of liquid is 1000. I can cancel this V and V. I can shift that 1000 on the opposite side. So I will be getting 2 into 1000, which is how much? 2000. Divided by 3, which is equal to density of solid. Can we solve this thing further, Bacha? So when I solve this thing further, I will be getting 666.67 kg per meter cube. I think this is what I'm getting as the density of solid. Can we complete it, guys? Maisha, you're getting it how to solve?
Yeah.
If we are done with the first one, we can try the second one. Huh? Should we start? Let's take the second, guys. So the second question is here. Maisha, if you can read it for us, the second one.
Okay. A block of wood of mass 24 kg floats on water.
Stop. So mass is given to us. Mass is 24 kg. So we will write here mass 24 kg. Then
Yeah. The volume of wood is 0.032 meter cube.
the volume is 0.032 meter cube. Okay.
Yeah. Find the volume of block below the surface of water
Okay.
and the
Below the surface means small v we are supposed to find.
yeah, and the density of wood.
And density of wood.
And the
Okay.
density of water is given 1000 kg per meter cube.
Density of water is given to us 1000 kg per meter cube.
Yeah.
Simple. Okay. How we will calculate? This is simple. To calculate the density of the wood, that is density of substance, we will use the formula. Density is equal to mass upon volume. Mass is given to me 24. Volume is given to me as 0.032. So we will be straight away getting this thing as 24 into 1000 upon 32. I can solve this thing by 24 and this is 32.
16.
So 6 fours are. No,
3 and 4.
8 threes are. And this will become 8 fours are. Then this will be to 4
7 for 50.
4 ones are. And this is 25s are.
So it's 750.
So 0. So we will be getting answer as 750. So we get density as 750 kg per meter cube as my answer. Okay. Once I get my answer as 750 kg per meter cube, after getting the density, we have to use the formula. The formula is density of solid we found out. Now we are supposed to find out small v. So we have a formula which says that small v upon capital V is density of solid upon density of liquid. Small v we need to find out. Capital V, guys, it is already given to me, which is 0.032. I hope, Satvika, you are getting it. Is equal to density of solid is 750. Density of water is given to me as 1000. This 0 gets cancelled. So we will be writing this thing as small v is equal to 75 into 32 upon 100 I already had, and this will become 1000. I can go with 25 category. 25 threes are 25 fours. This is 4 ones. This is 4 eights are. Yeah. So 8 into 3 is 24. So we will get small v as 24 upon 100, which is 0.024 centimeter cube. Got it, Maisha? How to solve?
Yeah.
Sure. Third sum. Third, I will read it and then we will try. The third question is, they have instructed a wooden cube of side 10 centimeter. So side of the cube is given to me as 10 centimeter. So I can simply say volume of the cube will be 10 into 10 into 10, which is going to be 1000 centimeter cube as the total volume. They have instructed its mass is 700 grams. So the mass of wood is 700 grams. I need to find out what portion of it remains floating above the surface. So what part is above the surface I am supposed to find. So I will try to go with certain things which I already know. Now, since I know that my formula is small v upon capital V is equal to density of solid upon density of liquid. Kian, do we know small v ka value? Do we know capital V ka value?
Yeah, 1000.
1000. So we already know capital V. Do we know density of solid?
No.
No. But can I calculate it by
Yeah.
using the formula
Density
density is equal to mass upon volume? Mass of solid is given to me as 700. Volume of solid is also given to me as 1000. I cancel this thing, so I get density of solid as 0.7 gram per centimeter cube. Now it is immersed in a liquid, and that liquid is nothing but water. So water ka density, I know it is 1 GCM raised to minus 3. Now let's try to substitute these values in a formula. Small v is unknown, so it remains as it is. Capital V is 1000. Density of solid is 0.7 and density of liquid is 1. I cross multiply this thing. We will be straight away getting small v as 0.7 multiplied by 1000, which is going to be 700 centimeter cube. Now guys, listen carefully. This is the volume which is inside the water. But as for the requirement in the question, we need to find out what part is above the water.
Also, we minus it like 1000,
Yes,
700.
yes. The total volume is 1000. उसमें से how much portion is inside the water? 700. So what portion will be above the water? 300. So we will write volume above the water. Now here comes the twist. Volume above will be 1000 minus 700. That is 300 centimeter cube, guys. But I need to find out the part. The part basically means the height which is above the water. And that height will be calculated by this formula. Now, when I talk about volume, I know that volume is length into breadth into height. So this 300 which I have, that 300 is actually a combination of 10 into 10 into 3. So how much portion is outside the water? It is 3 centimeter is outside the water. Because length and breadth remains the same. The height is getting. Understood? We understood how we got 300.
Yeah, but
Oh,
300
also like
300 is
very
also.
So we do get 300 in other ways also. But when I do talk about the original length is 10, breadth is 10, and height is 10. If I have this as my object, or if I have this as my object, when I try to dip it inside, the entire length is inside the water. The entire breadth is inside the water. Only some portion of height is outside.
So basically, you can, yeah, got it.
So you need to only talk about in terms of height. Length to pura is inside the water. Suppose if I try to hold you here and I try to dip you inside the water, your entire length of the body will be inside the water.
Yeah.
Your breadth of the body will also be inside the
Yeah.
water. Only the portion in terms of height will be above and below.
Oh, okay.
Got it? So I need to find out how much part is outside the water. And the part which is outside the water is 3 centimeter. Okay? Let's complete it. After completing this, then we know what is the next question to be done. The sixth question. So the question number 6, Satvik, if you can read it for us.
A piece of wood of uniform cross-section and height 15 centimeters.
Stop. A piece of wood of uniform cross section means length and breadth is same, and its height is given to us, which is how much?
15 centimeters.
15 centimeters. So if I want to write the volume of the wood, I will write the volume of the wood as L into B into 15. Instead of height, I will write the number. That is 15 centimeter, which is given to me. Continue.
Vertically with its height 10 centimeters in water and 12 in spirit.
Okay, so when it is dipped in water, the portion above the water or below the water?
Dipped in water.
Dipped in water, its height is 10 centimeter in water. So 10 centimeter, it goes inside the water. So volume in water will become L into B into 10. In spirit, it is going to become how many centimeter?
12.
12 centimeters. So in spirit, it will be the volume as L into B into 12. Continue, bacha.
Find the density of wood and spirit.
Find the density of wood and we need to find out the density of spirit. This is easier. I need to solve this sum into two cases. My first case of the sum will be when the wood is inside the water. That is going to be my first case. And second case will be when this same wood is inside the spirit. Okay. So let's try to calculate wood inside the water. Let's try to do it simultaneously, guys. So even you are trying, even I'm trying. So we will use the formula small v upon capital V is density of solid upon density of liquid. Small v is the volume which is inside the liquid. So it is L into B into 10. Total volume is LB into 15. Density of wood, that is solid, is not given to me. So I'll write it as it is. But since it is dipped in liquid, I will take density of water as 1 because everything is given to me in CGS. Okay, so I'm writing here density of water is 1 GCM raised to minus 3. I can cancel this length and breadth better. Length and length gets cancelled, breadth and breadth gets cancelled. This is 5 2s are and this is 5 3s are. 2 upon 3 would give me how much?
0.66666.
So we will be getting density of wood as 0.67 GCM raised to minus 3. Maisha, you are with us, right? And you are understanding.
Yeah.
Okay. Now, Kian will help us to solve the second part. How we will calculate the density of spirit. Can we use the same formula?
Yeah.
So small v upon capital V is equal to density of solid upon density of liquid. Now, when it was dipped in spirit, how much portion was inside the spirit? The volume was
2/3.
it is L into B into 12. What is the total volume of the cube?
Um, uh,
It is L into B
Oh, L
into
into
15. Density of solid is 2 upon 3 or 0.67. I would suggest you all to take it as 2 upon 3 into density of liquid I'm supposed to find out. I can cancel this LBH. So when I cancel this LLBB, I will get this as 3 4s are and this will go 3 5s are. Density of liquid, I'm shifting it on the opposite side. And all these numbers, we will shift it on the other side. So check the calculation. It is DL is equal to 2 upon 3. Already I had 4 from the numerator will shift down and 5 from the denominator will shift here. This is 2 1s up. This is 2 2s up. So DL will be 5 upon 6, which would be 0.
wait. 0.1 something.
6 and this is 5. So this is 0.
Oh, no.
50.
1/6 would be that. 1/6.
8s are 48, which will give you 20. 3s are 18. Yes, I'm getting 0.83 GCM raised to minus 3. This is my answer. This is the density of spirit and that was the density of wood. Clear? Sure.
Yeah.
Let's try to solve the next question. So we'll now solve 7 and 8 both together. So question number 7. So here goes question 7. Just look here now, guys. A wooden block floats in water with its 2/3 of the volume submerged. Submerged means small v is given to me. 2/3 of its total volume is inside the liquid. We can say let the total volume be capital V. So we will write here total volume as capital V. Then calculate the density of the wood if it is in water. So density of liquid, I will take it as 1 GCM raised to minus 3. Density of wood is supposed to be found. So which formula should we prefer?
the U upon
Small v upon the capital V equals
yeah, upon the
Small v upon capital V is equal to density of solid upon density of liquid. Small v is 2 upon 3 V times upon V. Density of solid I don't know, and liquid it is V.
so cancel.
I'll cancel this V and V. On cancelling this V and V, I will be getting density of solid as 2 upon 3, which will be 0.67 GCm raised to minus 3. This is the density of wood which I have found. After calculating the density of wood, I'm supposed to find out if the same block is placed in oil, 3/4 of its water is immersed in oil. So this is my first part. If the same block, if it is inside the oil, how much portion is inside? 3/4. 3/4 means 3 upon 4, right? So small v at that moment of time will become 3 upon 4 times its original v. We are supposed to find out what is the density of oil. So density of oil means density of liquid I am supposed to calculate. So if I try to solve this part, I will be getting that same formula, small v upon capital V, density of solid upon density of liquid. But in this case, how much is the small v? It is 3 upon 4 times the capital V divided by capital V. Solid ka density is 2 upon 3 because same block is given to me. So
Okay.
initially that wooden block which we had, same block we are using. Same block. But only difference is we are having density of liquid as different values. So I'm writing it as di. Right? Here initially I had water. Now in this case, guys, we are having oil. So we need to find out the density of oil. I can cancel this V and V. We can shift that dl here on this side. So we will get dl is equal to 2 into 4 upon 3 into 3. So we will be getting dl as 8 upon 9. And 8 upon 9, when we try to solve, we will be getting our answer as 0.8.
0.7. Oh yeah, 8.
No, 0.833 GCM raised to minus 3. Okay, so this is how we will be getting our answer. We got it, Satvika? This is the B part, which I have tried. Let me try even the 8th one, and then we can make a note. Let's try 8th one also. 8th one, Kian, can you read it for me, bacha?
The density of ice is 0.92 gram centimeter minus cube.
So I'll write here density of ice. Here ice, I think it is going to act like a solid for me. So 0.92 GCM raised to minus 3. Continue, beta.
And that of seawater is 1.025.
Can I say seawater will be acting like a liquid for me?
Yeah.
Which is 1.025 GCM raised to minus 3. Continue.
Find the total volume of an iceberg which floats with a volume 800 centimeter cube above water.
So total volume means capital V we are supposed to find. Total volume bracket capital V is question mark. And how much portion is above? So volume above it is 800. So we can write here volume above the water is 800 centimeter cube. So guys, can you tell me what will be the small v? Can I say if total volume is V and the portion above it is 800, so can I say it will be V minus 800 as the volume inside the liquid? Right? See, if the total volume is V, from which the portion above the water is 800. So what will be the portion below? It will be the total volume minus the volume which is outside. That will be V minus 800. Let's try to substitute in a formula. So we have small v upon capital V, density of solid upon density of liquid. Small v is V minus 800 and capital V is V as it is. Density of solid is 0.92. Density of liquid is 1.025. We cross multiply, guys. So when we cross multiply, this will be 1.025 V minus 800, 1.025 is equal to 0.92 V. Now, Satvika, we will need your help.
I can't hear you, sir.
You can't hear me? Can you hear me now?
Yeah, little more, but it's very soft.
Am I audible now?
Yeah.
Okay. So we will multiply this thing. 1.025 into 800 is
1.025 into 800.
yeah,
820.
it is 820 is equal to 0.92 V. 820 goes there and 0.92 comes here. So we will get 1.025 V minus 0.92 V is equal to 820.
0.105.
So this is 0.105 V is equal to 820. So can I say V is equal to 820 upon 0.105, which would be
It's a big number. 789.523.
789.523
523.
centimeter
There it
cube.
goes.
Probably this should be the answer.
7809. Yeah, that's what I said. Oh no, sorry, 789.
It is 7809. Okay, so it is 7809. Can you say again, Satvika? It is 78009.5
9.5.
centimeter cube. ठीक है? Maisha,
Yeah.
you understood how to solve?
Yeah.
Okay, ठीक. Let's try to solve. Yeah. Just a minute.